is y plus half all square. And if you are doubting that, I encourage you to do the expansion and see that it will give you y squared plus. Hello and welcome to today's edition of our videos. We are going to solve question number 16 in this video. All you need to do right now is to grab a paper, a pen, sit down, grab yourself a bottle of water or juice, and let me take you through the procedure of this particular question. Question number 16 says, we should solve the differential equation dy by dx equals to y squared plus y plus 1, or divided by x squared plus x plus 1. So to solve this problem, we are going to separate variables. So to separate variables, we multiply this out by dx, and we divide this out by y squared plus y plus 1. So we have dy over y squared plus y plus 1 equals to dx, or divided by x squared plus x plus 1. Once we complete this, we can integrate both sides. So we have the integral of dy over y squared plus y plus 1 equals to the integral of dx, or divided by x squared plus x plus 1. In the calculus tool, you learn how to integrate expressions like this, and we're just going to go through the procedure of integration. To integrate this, we have to complete the square in the denominator. We have the integral of dy over y squared plus y. We find half of the coefficient of y. In this case, the coefficient of y is 1. So half of 1 is half. And then we square that result. So we have plus half squared, that's 1 over 4. And then we have plus 1. Remember, we should add it, and then we should also subtract it. So we add 1 over 4 and subtract 1 over 4. Because if this and this cancel out, we go right back to the same expression we started with. This equals to the integral of dx, or divided by x squared plus x. We can perform the same completing the square method in the denominator of this. So we have 1 over 4 plus 1 minus 1 over 4. So this is a perfect square. We have the integral of dy, or divided by y plus 4. Plus, and if we simplify 1 minus 1 over 4, we have 4 times 1 is 4, 4 minus 1 is 3 over 4, equals to the integral of dx, or divided by, this is a perfect square, so you have x plus half all square plus 3 over 4. Now, this resembles tangent inverse of x, but we must have, obviously, an a square. So we say note that anytime you have the integral of the x over s squared plus a squared, that is 1 over a, tangent inverse of x over a, plus some constant c. This is an expression that's already been derived, and we just are going to use it right here. In this case, this is our x, this is our a, but this a has to be squared. So I'm going to rewrite that. The integral of dy, or divided by, this is y plus half all square plus, we want to write 3 over 4 to have a square. So we're going to write it as the square root of 3 all over 2 and all square. This equals to the integral of dx, or divided by, parenthesis will be x plus half, the closest all square, plus the square root of 3 over 2 and all square. Once we do that, we notice that these expressions are similar to this. So go right ahead and apply this on each of these. Now, in this case, our a is y equal 3 over 2 all square, and our x is y plus half. So we're going to have 1 over, it should be 1 over a, but a is root 3 over 2. Tangent inverse of, it should be x over a, but x is y plus half, or divided by a is root 3 over 2. This equals to, apply the same thing here, 1 over a, so it's 1 over root 3 over 2, and then tangent inverse of, this is x plus half, all over root 3 over 2, and then we have a plus c, where c is the arbitrary constant. We can notice that this and this will obviously go out. So if you multiply the entire equation by the reciprocal of this and this will cancel out. And if you affect the constant c, that will still be c. So we'll go right ahead and simplify. We have tangent inverse of, this time this is 2y plus 1. So this is 2y plus 1. And the denominator and this denominator will go out. So you just be root 3. It's equals to tangent inverse of, this will give you 2x plus 1 over root 3 plus c. Now this could be our result. This is the answer to this question. But if we want to simplify more further, we can say this across. We have tangent inverse of 2y plus 1 over root 3 minus tangent inverse of 2x plus 1 over root 3 equals to c. We can combine these two by using tangent inverse of x minus tangent inverse of y is equals to tangent inverse of x minus y over 1 minus xy. This is an identity that we want to use. This is tangent inverse of x minus tangent inverse of y. This is y, this is x. So we have tangent inverse of, the entire result will be tangent inverse of x is this, so it's 2y plus 1 over root 3 minus y is this, 2x plus 1 over root 3 all divided by 1 minus xy. So it's 1 minus x is this, 2y plus 1 over root 3, and y is this, 2x plus 1 over root 3. And then we have equals to c. So if we do that, we can simplify more further. We will have tangent inverse of, now we can take one of the denominators and subtract the numerator. So we have 2y plus 1 minus 2x and minus 1 all divided by, now this is root 3 on here, and this entire thing is divided by 1 minus, we can do the multiplication. This time this is 4xy, so I'm going to put that in parentheses, 4xy. This time this is 2y plus 2y. This time this is 2x plus 2x. And then this time this is 1 plus 1. All divided by root 3 times root 3 is just 3. Great. Now that's equal to c. So we have tangent inverse of, why do we notice here? Negative 1 and positive 1 go out. So we have 2y minus 2x over root 3. And this is divided by, this time this is 3. Negative will affect everything. So it's minus 4sy minus 2y minus 2x minus 1 all divided by 3 equal to c. So you have tangent inverse of, this is 2y minus 2x over root 3 divided by, we simplify it. This and this will give you 2. So it's 2 minus 4sy minus 2y minus 2x over 3 equal to c. So we can rewrite tangent inverse of, factor out of 2 here, we have y minus x over root 3. We change this division sign to multiplication. So it's times, 3 goes up, and then here you have, we factor out 2 from here, 2 parentheses opening, 1 minus 2sy minus y minus x equal to c. So what we observe is that this 2 and this 2 goes out. This root 3 will go here root 3 times. So it's tangent inverse of, this is y minus x times root 3 all divided by 1 minus 2sy minus y minus x. Everything is equal to, I can write it as tangent inverse of c. And then when I take tangent on both sides, I'm going to have y minus x times root 3 over 1 minus 2sy minus y minus x. Everything should be equal to c. And again, cross multiply, so I'll have y minus x times root 3 is equals to c multiplied by 1 minus 2sy minus y minus x. And this, ladies and gentlemen, is a solution to this differential equation. Thank you very much for watching, and we'll see you in our next video.